Comparing functions. When you model a real-world situation, it's important to select a suitable modeling function. To make the best choice for a given situation, you need to know the characteristics of a linear, quadratic, and exponential functions. Tools that you can use to aid in this decision includes graphs, finite differences, ratios, and equations. We're going to consider the following 3 different equations. We're going to consider that one. We're going to consider that one. And we're going to consider that one. Now, looking at these, you should know the difference. You should know that this is linear. You should know that this is quadratic. And you should now know that this is exponential. Linear equations look like this. Quadratic equations look like this in standard form. And exponential equations look like this. That's how you're going to be able to tell them. So classify each as linear, quadratic, or exponential. I think I did that. And explain how you know by referring to the equations. Because this has a degree on the variable of 1. Don't tell me it doesn't have an exponent. You guys like doing that on the test, and I'm going to take marks off for it if I ever see it again. It does have an exponent. It has an exponent of 1. And we say that it has a degree of 1. This one is quadratic because it has a degree on the variable of 2, which means that there's that little 2 up there. So this has a little 2 up here, and this one has a little invisible 1 up there. Now this one, well, this one, the variable is in the exponent. Now remember, we talked yesterday that the whole thing is called a power. And we often do that wrong, right? We often call that an exponent, and it's not. This is a power. And I guess we should call them power functions then too, instead of exponential functions, but we don't. So I understand the confusion, I really do. But the variable is in the exponent, so it's up there now. This has degree 2, this has degree 1. That's how we know what they are. So, complete the table of values and sketch all 3 relations. Ooh, that's a great word from the past. Relation. It means an ordered pair. Okay, so it's going to have a first value and a second value. That's a relation. All 3 of these are going to be relations. We're going to sketch them on the same graph. So, when x equals -3, -3 goes in for x. -3 times 2 is -6, plus 1 is -5. When -3 goes into x here, it becomes squared, which is 9, minus 1, it becomes 8. And when -3 goes in here, it becomes 2 to the -3, which is 1 over 2 to the 3, which is 1/8. And I'm not going to write it as a decimal. I'm going to leave it as that. So my 3 answers, or my 3 y values, are going to be 5, 8, and 1 over 8 for that x value of -3. Well, we get to do the same thing again. -2. So that'll be -4 plus 1 is -3. This will be 4 minus 1, which is 3. And this will be 1 over 4. This will be -1. This will be 0. And this will be 1/2. This will be 1. This will be -1. And this will be 1. This will be 3. This will be 0. This will be 2. This will be 5. This will be 3. This will be 4. And this will be 5. Oh, I can't get 5 twice. What did I do wrong? 3, 6, 6. That'll be 6? No. 3 in here is 6 plus 1 is 7. Wow. That was a problem. And then 3 goes in here, which is going to give 8. And then 3 goes in here, which is going to give 8. Coolio. All right, so I guess we want to sketch these. All right, all right, all right. Hey, that's a song. All right, all right, all right. That's oh yeah, or hey yeah, or something yeah. I don't know. Da, 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 da. Maybe I'll find it and link it to this video. Da, 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 da. What's cooler than cool? Ice cold. Okay, so let's graph the first one. So it's going to be -3, -5. I guess I need a scale here. Oh, I don't like that scale. I think they want me to use down here. I think they're trying to show me something here. This seems a little bit darker. So use that for X, and this seems a little bit darker, so we'll use that for Y. So let's see, let's come out a little bit. What do we want to go? The X's, I think I'll make it 1, 2, well, I could do that, or I could do 1, 2, 3. That might be nicer. Why don't we make that 1, make that 2, make that 3. That'll be -1, -2, -3, because that's all I've got to go on. So maybe that's a little bit nicer. And the Y values. My highest Y value is 8. My lowest is -5. So 1, 2, 3, 4, 5, 6, 7. Yeah, why not? So 2, 4, 6, 8 will be about here. And this will be -2, -4, -6 about down there. Okay, so let's start graphing them. The first one, the one that this one, the linear one, that's going to be all of these points, right? So it's going to be -3, -5. So there's -5 approximately. There's approximately -3. -2, -3. About there approximately. -1, -1. Out there approximately. You couldn't see where I went. Haha. So -3, -5 approximately. -2, -3. -1, -1. 0, 1. 1, 3. 2, 5. And 3, 7. And we get, not surprising, a line. Hence, it was a linear function. That really shouldn't be surprising to anyone. We get this guy. And that really should not be surprising given that its equation was that. So that's grade 9. That was fun. Okay, so I guess I'm going to go after the next one. I'm going to go after the quadratic. Now, these are all the points for the quadratic, so I could go to -3, 8. Oh, wow, -3, 8 is way up here, I guess, approximately. And then -2, 3 is here approximately. -1, 0 there. And then 0, negative, oh no, -1, 0. Oh, tricky, tricky. Get rid of that. Put it back in. There we go. And then I should have 0, -1. And then I should have 1, 0. So I guess we found our vertex, right? It's coming up now. 2, 3. And 3, 7. Oh, look, it's going to cross here. So this is going to, now that I need to make this nice and smoothie. So smoothie, smoothie. And you know what's going to happen after 3? It's good. What? Oh, it's 3, 8. It's up 1. Thank you. Thank you, studio audience. That's even better. It's going to come up. It's crossing. Look at that. Look at that. And then this is going to come up. Thank you, studio audience. Okay, so you'll see that it's come above the linear one now. There we go. And this is given by y equals x squared minus 1. That was fun. And there's an arrow on the end there. And the next one is going to be this one. So I'm going to go to -3, 1/8. Well, -3, 1/8 is maybe there. -2, 1/4. Well, maybe there. -1, 1/2. Maybe there. 0, -0, 1. Sorry, not negative. Is there. 1, 2 is here. And then it's 2, 4, which is 2, 4 here. And then it's 3, 8, so it's going to hit here. And you know if I go past it, it's going to come up above the parabola, right? They're going to separate there. So this equation, this function looks something like this. So it's going to start getting above as I go that way, and it's going to look something like this. And that's what they're all going to look like. Now I'm going to pause the video here. You can keep the video going and finishing your graph, but I want to pause the video and do something, and I'll be right back.